Okay, welcome to my online classes. This is Dr. Esmoda, Professor, CSC Department in Guru Nanak Institution's Technical Campus. Today I am going to discuss the measure of variabilities. Mostly I will concentrate today on variance, standard deviation, covariance and correlation of the variables or correlation of the attributes or correlation of the features. Okay. Last class I discussed the concept range, middle range, IQR, variance, standard deviation, covariance and correlation. So let's see that definitions once. So I think here range, the range of the data points are objects on the space. So that is how the data is spread in the given space. So for that we return the some thing like, so let us take that 65, 81, 73, 85, 94, 79, 67, 83, 82. These are the data points. The range is max minus min. The maximum value is 94 in that, 65 is the minimum. It will get 29. So now here the spread of the values are between 65 to 94. The range will be 29. The mid-range is always can take that large value plus smaller value by 2, that is 79.5. The middle of that 65 to 94. Other one is that interquartile range. So that is median, middle of the first half and the middle of the second half, a measure of spread. So when I have taken the values here, all the values are data values or data points in increasing order. So 4, 4, 6, 7, 10, 11, 12, 14 and 15. So in that first you have to find out the mid value. So what is the mid value there? That is called the median of the complete data points. About all 4 plus 4, 8, 9. Out of 9, the mid value is the 10. Okay. So now that is the median one. Again, left half will be divided into two halves. So left half is having only 4 data points. So the median of the left half will be median two values average. That is 4 plus 6 by 2. That is 5. That is called median 2R can be said as a quartile 1, Q1. So another half like a right half. When I taken that 11, 12, 14, 15, under that again median will be what? 12 plus 14 by 2, 13, quarter 3. So now I can define the IQR equal to Q3 minus Q1. So that it will give the, what is the IQR of the data points, that is 5 plus 13 by, because 13 minus 5 equal to 7. That is the IQR value of the data points. I think all of you understood. Yes, all of you understood this? What is IQR? Okay, okay. I am going to share other one also, that I will. New share, I'm taking this as a word. Okay. There's a way you can define the range, mid-range, interquartile range for the data points. The next one is that percentile of the data points. So value below which percent of all data falls. What are the values are below that percentile? For example, you take 80% of people are shorter than you. That means you are at the 80th percent. So they are given that here English percentile 56, 75, 45, 71, 61, 64, 58, 80, 76 and 61. First you have to sort all the numbers. So then what is the highest value here? 80. So 80 below is what? All the values which are comes under, just like calculating a percentage. Suppose you take that as the threshold value. What are the below that? What are the above that? For that range only we are going to use the percentile. So now we are not going to discuss anything about that percentile. Okay. Okay. Next. The next one is that most important thing is that now we are going to discuss the variance. So before going to discuss variance, let's see that what is the measure of variability, how the data is spread over the space, over the complete population. So here is that all of you observe that there are two bar charts. There are two bar charts. What is that? Still people are coming. Yes. So now all of you observe these two bar charts here. Okay. Now see that quiz one. Quiz one. There are two axes, x-axis as well as y-axis. X-axis is the scores, y-axis is the number of students. So all of you observing this one? Yes. X-axis is what? Score. Y-axis is the what? Number of students. Now the scores are here 4, 5, 6, 7, 8, 9, 10. But in case of 5 score is having 2 students. 6 score having 6 members. 7 score having 5 students. 8 score having 4 students. 9 score having again 3 members. So now the score will be spread it into the 5 2 times, again 6 times. That is the same data is repeating. Same data value is repeating. 7 is again 5 times and 8 is again 4 times. 9 is again 3 times. Adding up all this, it will get 20. Again, they are getting some disturbance here. People are joining. People are joining. So anyway, you have to admit that. Next. So when if you take that another one bar chart, another bar chart. So what is the second one? Now what is the second one here? Again same x-axis. Same x. Hello? Okay, x-axis is the score, y-axis is the okay. X-axis is the score, y-axis is the students. Okay. So now here 4 score got 2 members, 5 score got 4 members, 6 score got 3 members, and 7 score got 3 members, 8 score got 2 members, and 9 score got 3 members, and 10 score got again 3 members. So when if you see that both the graphs, the Q1 graph, like a quiz 1 graph having how many? 1, 2, 3, 4, 5 variations, 5 variation of his data points. So when if you come to the Q2, how many are there? 1, 2, 3, 4, 5, 6, 7. So now Q2 is spreaded more than the quiz 1. Quiz 2 is more spreaded than the quiz 1. That means the value of the variance will be more in the Q2. The spreading of data is more in the quiz 2 in when compared with the quiz 1. This is a way we can able to define that what is the spreading of data or what is the spreading of or we can say that called Now it is okay for all of you. Now it is okay. Yes.
No, sir.
Now also not getting.
No, sir.
1 minute. Let me see. Now it is okay. Yes.
Yes, sir.
Now it is okay.
Yes, sir.
Huh?
Okay,
Yes,
sir.
sir. Coming.
Now it is okay.
Yes, sir.
Okay,
Yes,
sir.
sir.
Okay. All have understood that IQR. IQR. Okay. Now I'll move to the spread of data. Okay. Measure of variability, that is spread of data. So this is very useful for the defining of variance or how the data values are spreaded on the space. Okay. Now listen here. Can you observe that quiz 1 and quiz 2? So there are two quizzes here. The quiz 1 is that having the one bar chart. All of you listening?
Yes, sir.
Yes. Okay. So there are two quizzes here, quiz 1 and quiz 2. So let's see that first quiz 1. There are two axes. One is the x-axis, other one is the y-axis. X-axis is score, y-axis is the number of students. So before completion of this concept, so let's see that in the quiz 1 chart, how many bars are there? 1, 2, 3, 4, 5 only. So now when if you come to the quiz 2, again having 1, 2, 3, 4, 5. See, listen here. 1, 2, 3, 4, 5, 6, 7. Okay. So by seeing of these two bar charts, we can say that quiz 2 data is spreaded more than the quiz 1 because the whatever the value taken for the quiz 1, quiz 2, total number of data points are 20 only. Total data points are 20 only. But quiz 1 is repeating the more same data. But quiz 2 is not repeating more data on the data points. So let's see that quiz 1 is having that 4 score is nothing, 5 scoring 2 members, 6 scoring is 6 members, 7 scoring 5 members, 8 scoring 4 members, 9 scoring 3 members. So now here is that 6 score is repeated many times, 7 score also repeated many times. Same data points are repeating on the quiz 1. When comes to the quiz 2, there are again 4 score 2 members, 5 score 4 members, 6 score 3 members, 7 score 3 members, 8 score 2 members, 9 score 3 members, 10 score 3 members. So now here the quiz 2 having more spread than the quiz 1. By seeing a bar chart also we can say that lot of variance is there in the quiz 2 than the quiz 1. But it is having some variance but not more than the quiz 2. Data points are more spreaded in the quiz 2. Data points are very closer to the center of the data for the quiz 1, but quiz 2 is center of the data will be away from the total all the data points. Okay. So next is that all of understood this graph? Yes or no? All have understood this graph.
Yes, sir.
So quiz 1 and quiz 2 graphs. Which is the more spreading? Which one is the most spreading? Q2. Okay. So already in the last class I given that example. Same data points are there, that is having less range, that is also having less variance. When more different data points are there, that is having more range, that is having more variance between the points. Okay. So now we see that what is the variance? Variability can also be defined in terms of how close the score in the distribution or to the middle of the distribution, using the mean as the measure of the middle of the distribution. The variance is defined as average squared difference of the scores from the mean. So now variance can be defined based on the mean. So always here variance will be taken with what is that? The symbol will be what? Lambda or what? What is the symbol? S. Sigma. Sigma square equal to, I don't want to see that complete whatever the calculations are here, not required. We can write the just simple formula. What is that? Sigma equal to 1 to n x minus mu whole square by n. So that is the actually what is that variance formula. So let's take that same variance for the two quizzes. Already I told that quiz 1 having the less variance, quiz 2 having more variance by seeing that graph. So let's see that numerical also, what is the value. So what is the value can be taken which is the having highest variance, for the same graphs. Okay. So what is the quiz 1 here? So there are 2 times already we saw that graph. Yes or no? So now correlate that graph with these values. What is the quiz 1? 5 score is how many? 2. 6 score is how many? 6 times. 7 score is how many? 5 times. 8 score having how many? 4 times. 9 score having 3 times. And quiz 2 also same thing. So now here quiz 1 is having 5 5, 6 6 times, 7 5 times, 8 4 times, 9 3 times. So total number of data points here is the 20, and quiz 2 also 4 2 times. So what I explained in the bar chart. Okay, 5 4 times, 6 3 times, 7 3 times, 8 2 times, 9 3 times, 10 3 times. So now for both quizzes, mean will be same. So it is sum of the quiz 1 will be 140, total is 20, that is 140 by 20 equal to 7. So here this is now quiz 2, again sum of all the quizzes will 140, total number of points is 20 equal to 7. Now apply these values on the formula. What is the sigma equal to n? All of you. Okay, sigma equal to 1 to n. What is that formula? X minus mu whole square by n. So now we have to find out that distance between the data point and mu. So whatever the values were taken on the data space, whatever the first point is there, 5 minus 7 whole square by what? By total 20, sum of all. So now here, what is that? 2 into 5 minus 7 means 5 is repeated twice. That's why I have taken directly 2 into 5 minus 7 whole square plus 6 how many times? 6 times repeating. That's why 6 minus 7 whole square plus 5. 7 how many times repeating? 5 times. So that's why 5 into 7 minus 7 whole square plus. Next, 8 how many times repeating? 4 times. That's 4 into 8 minus 7 whole square plus 9 is how many times repeating? 3 times. That's why 9 minus 7 whole square. So after doing that calculations, you will get the you will get that 3 by 2. What is that? Variance of quiz 1 is 1.5. Variance of quiz 1 is what? 1.5. So when it comes to the quiz 2, We apply the same formula, 78 by 20, that is you will get 3.9. Now see that in terms of number also, in terms of formula also, if you do the calculations, quiz 2 having that more variance than the quiz 1. All of understood this one? Yes or no? So what is that? Through the graph also we got that. What is that? Lot of spread is there in the quiz 2. So lot of spread is there means that is having highest variance than the other data point. Just now we see that quiz 1 and quiz 2. Quiz 1 is having less spread on the data. Quiz 2 having higher spread on the data. That's why it is what 3.9 is higher than the quiz 1. That's why I can say that quiz 2 is having the higher variance. All of understood this? Okay. Suppose all of you, for all of you, one general question. Suppose suppose I conducted that one exam for you. One exam for you. So what is the exam here? My exam is that for this all 40 members or 50 members or whatever it is, all are got same marks. All are got same marks. What is the variance of that? Yes. What is the variance of that? Yes. 0, 0, 0, 0, 0. I think all of you now understood. Yes or no? So we can relate this for the any data set. If more repetition of values are there, that is having less spread, less variance. So through calculations also it is proved. Through calculations also it is proved. It is having what? Less variance. Okay. Now see that another formula is given. If this is the another formula, so all of you please try to follow this. If the variance in a sample is used to estimate the variance in a people, then the previous formula understand the variance and the following formula should be used. So actually, whatever the standard formula is there, finding for the variance for the complete data set. So whatever the formula is given, S square equal to sigma x minus m whole square by n minus 1. That is for variance of a sample, not for the complete data. Understood? No, this is for what? Not for the complete data, it is for the only sample, for the sample one. So for that also it is actually mostly this kind of calculations are not required. Okay, so now I think all of understood that what is the variance. Yes or no? Okay. Next, you've got the standard deviation. This is very, very important. After this, I will try to give all the summary points regarding this. What the way we can use that variance and the standard deviations. What is the standard deviation? Standard deviation always what? Root of variance. Root of variance. So why you want to apply the root of variance means? So there is an average distance between the data points and mean. So there we can't able to find that what is the variance can be found, but we can't able to give that exact what is the distance between the data point and the mean. So that can be calculated by using the standard deviation. It is a measure that is used to quantify the amount of variation or dispersion of the set of data values. What is the spread of set of data values? That is what sigma equal to root of variance. That for the first is what you got 1.5 as a variance. Then standard deviation root of 1.5 equal to 1.224. Then if you go for the quiz 2, again root of 3.9 equal to 1.9. So what happened here? Again here distance between the data points and mean value for the quiz 2 is more than the quiz 1. I think all of you understood what is the variance and what is the standard deviation on the data points. Okay. Now we'll go for that one by one point. Again same what I discussed in terms of example, in terms of bar chart about the variance and about the standard deviation. Please try to listen. This is a very, very important point. Now actually Zoom always it will take only maximum 40 minutes limit for the time. If it automatically extend, I will extend. Otherwise, I will again restart the session. You have to once again log in your things. Okay, all of understand this one. If it stops in the middle within 40 minutes, again I will restart session. So within 2 minutes, you have to rejoin again. We have to close that today. What is the variance and what is the standard deviation on the data sets? On one example. Okay. Now see that variance can be applied within a column or variable or features. So that's why it can be applied for only variance, applied for only variable or attribute or feature or for the column wise. That is the respective towards respect to variable or feature. The variance is what? The average of square difference between each data point and mean. That's why x minus x is what? Data point minus mu. Mu nothing but a mean whole square by n. That is sum of all. Next, variance is a measure of variability that is utilizes all the data. So we can able to use that variance for the complete data of the column, not for only single observation of that column. It is based on the difference between the value of each observation and the mean. Each observation is data point only. Next, variance is useful in comparing the variability of two or more variables. So this is very useful for the comparing of a variance between the two or more columns or two or more variables or two or more features. So let's see this variance. Yes. Okay. We discussed variance and standard deviation. So let's see that how we can apply this for the data sets. I think from this picture also you got that what is the having, which is having higher variance, which is having lesser variance. Blue color gems are having no variance, that is equal to 0. How you got the, everyone got same marks like that. Other gems, different colors having variance is there, some difference is there. Okay. Now see this. So I think you see these formulas. What is the variance is for the observation like x1, x2, x3 up to x4 up to the xn. Sigma square equal to sigma equal to n xi minus mu whole square by n. So here xi is what? Observation or data point. Mu is what? Average of all the data points. Whole square, that is the distance between observation point as well as mean. Whole square by n. This is the standard deviation what? Sigma equal to root of variance. Root of variance equal to what? Sigma I equal to 1 to n xi minus mu whole square by n. So this is the what? Formulas regarding the standard deviation as well as what? Variance. Okay. So now see this, all of you write down this table. Write down this table. Now